Hi, this is Toby Stroud. Just doing a little explanation of PLCs, how a PLC runs, and where it fits into the ISA95 framework. If we look at ISA95, you got 4 layers, 1, 2, 3, and 4. Or if you count from the bottom, depending on how you look at it. But these 2 bottom layers is where controls engineers hang out at, and the PLC is in this second layer from the bottom. If you look at the modern way of looking at ISA95 with Internet of Things, then you can see how data has expanded, and we are segmenting between edge computer and cloud, or this could just be an on-site server. So it doesn't have to be in the cloud. In this example, taken from a SAP blog, they were talking about energy, and they have plenty of data that's going to the cloud. You may not have that kind of data. But if you look at it as applications and intelligence and just put it as manufacturing intelligence, then you can create whatever you need to support your business on this upper half of the triangle. For controls, we're in the lower half. PLCs and SCADA are on the lower half. Now, if you look at a PLC and how it gets the sensor data to the upper part of the ISA95, when you boot up a PLC, the power is turned on, the PLC loads its firmware, and when it does that, it goes out and checks what kind of sensors it's actually connected to. At that time, after startup, it will reset its outputs to initialization values, or in some cases, what it was stored last. Then the field bus will be updated, and field bus would be your Profinet or your Ethernet IP, however you are talking to your field devices. Next, we'll read the input values from the field, and then we'll execute the PLC programs. Keep this in mind for a minute. Once the PLC programs are executed, then you'll update the outputs. The cycle will repeat. You'll go back to updating the field bus step. You'll go back through reading the changes that are inputting, and then the PLC program will continue to make decisions. This is one reason why you need to look at being efficient with your PLC code, because you can affect your cycle time depending on your application. Now, controls is looking at everything that's in between, but we also choose the instrumentation and the devices that are inputting into the program for the PLC, and then specifying what we're talking to on the output side. Smart devices would be your HMI. Drives could be related to your motors. This is just an example, and the idea would be that we're monitoring an action in real time, and you're outputting a result or a response to that input. Controls engineers look at what the inputs and outputs that are needed in the process for the process to occur, and creates the program to generate the outcomes. This should be specified in a control specification, where you write down on paper what you want your inputs to be and what your outputs are going to happen or occur with whatever state that you are getting your inputs in. So input A plus B, divided by C causes ZY. whatever you want this to be has a set amount of actions or a set state that you are looking for to turn on that motor or turn on the light or e-stop, etc. And we can't do this by ourselves. We have to do this in conjunction with the mechanical designers. If you don't understand how the machine mechanically works, you can't really create code that's going to function with it very well. PLC programmer can be a separate person from the controls engineer. That's more geared toward just dealing with the PLC side. But a lot of times it'll be the same person. It'll be a controls system engineer that knows how to program. And that's understanding the devices that are coming in and then understanding the actions, the outputs. So to me, this is your connection to your process side, because you want your actions to match up with whatever your process control is. And then the inputs is going to be related to mechanical feedback, because you are always going to get an electrical mechanical response, and that feedback from here will cause the change in the process. So overall, it's inputs, system, outputs, and it could be like that. So mathematically, you can describe it before you even program it. So if we look at ISA95 in regards to changes that have happened recently with Internet of Things and the IT-OT convergence, then we are seeing some fuzzy logic in here with a demarcation point. This data acquisition area has gotten larger, and we are seeing it where we get sensors going all the way to the cloud. Again, you don't have to send it to the cloud. You can send it to a server that's on site, and then you can back up to the cloud as far as your historical data if you're not comfortable going edge to cloud. There's discussions out there about cloud being more expensive, people having issues with it slowed down, vision, taking up space, latency, etc. So your architecture has the ability, you can get real creative in here based on what you need for your business. And this is where the convergence is for IT-OT, and it will behoove us as controls engineers to learn more about the data side and understanding how we're converting here to stay up to date. So some resources: Industrial 4.0 standard ISA95, pathway to revolutionizing the energy industry through SAP. And this is where that diagram came from, and it's a good representation of how edge and cloud and this factory level demarcation point for IT-OT has been changing. It is in relationship to energy and oil and gas, and they have a lot more data going on than what most discrete manufacturers have, but regardless, this has been a huge increase in recent years. The other one is just Automation Direct with basic education of how a PLC runs. And to me, understanding this as far as how your data is coming through here and where your outputs are going to be, then that will allow you to segment field devices and then your SCADA side. These two need to be in two different locations so that these can update and be used in here, but this can update and be picked up by the ERP or MES. And that way it's a standalone and it doesn't affect that side. So that's why I brought it up in relation to Internet of Things and ISA95, because you have a direct link from the PLC to ISA95 data. Thanks for listening, and I will try to make these more professional as I go.